So now we will discuss the Viptela policy architecture. So initially, when you get your overlay network from Viptela, there are no policies configured. By default, there is no policy. Every route from every branch can go to the other branch. But if you want to control your routing, or if you have a specific requirement, then you can configure policies. So that's how the policy looks like. There are two type of policies. One is called control policy. The other one is called data policy. The control policy, it affects obviously the control plane, and the data policy, it affects the data plane. Now, further control policies are two types. One is called the centralized policy. One is called local policy. So centralized policy you define on the centralized controller, and it affects the entire network. The local policy you configure on each local. Actually, you configure policies always on the vSmart controllers, but the local policy, it affects only the local site routing. And the same thing with data policies. You have centralized and local. Centralized data policy, it affects the network-wide data traffic, and local data policy, it affects only a single interface on a single router. And as I mentioned, by default, no policy is provisioned. So centralized policy refer to a policy on a vSmart. Okay, I take it back. So the centralized policy is configured on vSmart, which is a centralized controller. And localized policy is basically provision on a vEdge router, which sit at the network edge of a branch. So any local policy you configure on vEdge, any central policy you configure on vSmart. So the centralized policy, there are two types. One is control policy, one is data policy. The control policy, it affects the flow of routing information, and the data policy, it affects the flow of data traffic. Then localized policy, it affects the local flow of routing traffic, site local flow. Any site where the vEdge is placed, it will affect only routing information in that local site. And also the local data policy affects the data flow in that specific vEdge interface. So if you see this table, so this table is a vSmart and vEdge, showing vSmart and vEdge. So all centralized policies are configured on vSmart. All centralized policies are also applied on vSmart. However, where policy execute depends on the type of the policy. So if you see this table, you can see the first one, the first row, which says configure. So there are different type of policies: app route policy, float policy, control policy, data policy, VPN policy. So we will look into these type of policies in the upcoming slides, but for now, just see that all these policies you configure on the vSmart controller. You also apply these policies on the vSmart controller. But as far as execution is concerned, so the control policy you execute on the vSmart, VPN policy you execute on the vSmart, but if it is app route policy, then you execute it on the vEdge. If it is float policy, you execute it on the vEdge. And if it is data policy, you execute on the vEdge. So there are three types of policies that you execute on vEdge, and the rest of the policies, control policy and VPN, you execute on the vSmart.
Faisal, I have a very quick question. In the other flows that I've seen on explaining this SD-WAN solution by Cisco, they go through the bring up process, and then they don't go to policies first. They first go through the data plane and then the overlay management protocol, and then they dive into policies. There is something different in your flow. You want to talk about policies first. Can you guide us? Why do you think it's important to talk about policies before we get into data plane and OMP?
No, we already discussed the data plane and OMP and everything. So if you go back, I started like there are four. I think I have in one of the slide I have shown you there are four important things. One is the secure architecture, then fabric operation, then application policies, right? So so secure architecture we have finished. Then we went to the fabric
Okay.
operation that we have done. Now this is the third thing, that is the policies. Data plane and everything we have already discussed in the secure architecture.
Okay, sir.
So every policy has a certain number of certain components. These are the components that we need to define and to construct a policy. So number one is list that we need to create. Then we need to create a policy definition, and the third thing is to apply that policy. So a list is a group of related items, like you define a prefix list, you define a site list, you define a TLOC list, or you define a VPN list. So let's say for site list, you will include all those sites where you want to apply this policy. Let's say site 1, site 2, site 3. So you make a list of the sites. Then VPN list. So you make a VPN list. Let's say you have configured 5 VPNs in your network, VPN 1, VPN 2, 3, 4, and 5. So you include the list of those VPNs where you want to apply this policy, which VPNs you want to cover. Then the policy definition, where you create the policy rules and you specify some match conditions, and then based on those match conditions, you take the actions. Third thing is to associate that policy with a site or with a VPN in the overlay network. So if you see the bottom three boxes, so the leftmost, it is showing you the list, the example of list. How can you create the list? So the first one, if you see, it says list and then data prefix list. Data prefix list is like you put some kind of IP address or port number, like this. This is showing you an example of IP address 1.1.1 /32, port number 100. So you can create a list of IP addresses which you want to be impacted by that policy. So you make a list. Then you can see the second option, which is site list, and you see there is a site ID which is 100. So when you apply this policy, this will impact only the site 100 routers, or it won't impact any other site. And then you have a TLOC list, so you can define a TLOC which is showing the system IP color and the encapsulation. And then the VPN list, it's showing you a VPN 1. So this policy will impact only VPN 1. The next box, if you go, it's showing the policy definition. So in the policy definition, you first of all you assign a name to that policy. Then let's say you're defining it for VPN list, you say VPN list and then the name of the VPN list. And every policy, whatever match conditions or rules you apply, you assign a sequence number to that. So you assign first sequence number and you say match. Now you can match either a route, you can match a TLOC, you can match a VPN, and then what action you want to take. So if, let's say, this policy has matched that route, or if this policy has matched that VPN, what action you want to take? You want to take either accept that, you reject, or drop it, right? So, and then the third box is showing you how to apply or associate that policy. So you go to this, you define it like apply policy, and then the next line you show site list where you want to apply this policy. So whatever site you will mention in site list, it will automatically apply those policies, that policy to the site included in the site list. So that's how you configure or you construct a policy. And this is one of the examples of the policy. So it creates two lists. One is the site list and other is the TLOC list. So basically, if you see the order, it is reverse, right? So initially, we said we have to define a list, then policy definition, and then apply it. But when you write the policy, it is in the opposite order. So the first part is showing you how to apply the policy. Second part is showing you the policy definition, and third part showing you the list. So when it appears on the router, it appears in the reverse direction. So start looking at the bottom, the purple box first. So we have created two lists. One is the site list, and it has included, so the sequence number is 10, and we are saying, okay, match route, and then match route in site 1. And when you match that route, accept it, and what action you have to take? You have to set a TLOC preferred by the site. So in the previous slides, we have discussed that it's up to you. You want your voice over IP traffic to take TLOC 1, your let's say multimedia traffic or video streaming traffic, you want to take TLOC 2. So that's how you configure policies here. So you say, okay, match this site, and then set this TLOC. So when for this site, when traffic will go out, it will take that particular TLOC. So on the on the blue box on top of that, you define this policy that list site list 1, site ID is 100, and TLOC is this one, and then the color of the TLOC you define. And then on the top of the top green box, you apply the policy to that site. So it will only affect that particular site which is included here. This was just an example, basic example of how you configure policies on the controllers.
And in this particular example, you're trying to explain that if your specific type of traffic should be sent over a specific type of TLOC, which is in this case MPLS.
Right.
For IPsec preference, 400 is what is 400? Is it the VP? What is the preference 400 here?
So the preference value is when you have, let's say, 2 exit paths from the branch office. You can define preference. So whatever path has higher preference, the data will get exited from that higher preference link.
And so if you
by
define
default,
that,
every link has the same preference. But if you want a certain type of data to exit out from the branch, you can assign a higher preference.
So voice will be given a preference over data, for example.
Yeah, whatever type of traffic you select in your policy, and then you can assign a higher preference to go out from a certain TLOC.
Excellent.
All right. So there are some other type of policies also beside data and control policy we have seen in the table also. One is called application aware policy. Application aware policy basically track. This is the one of the question I think Tariq or somebody has asked initially, that how can you get the same SLAs in the internet which are close to the MPLS service SLAs. So that's how, using these application aware policies, you can define SLAs on the internet circuit. So application aware policy track packet loss and latency on the data plane connection between the VH routers to compute optimal path for data traffic in the overlay network. So let's say if you have one path and it has some kind of issue and packet loss or latency, then it will switch that path and it will send the data through another path which has a better latency. So you define your SLAs basically using these policies. So this policy specify the performance characteristics in the form of SLA, which defines the required latency and loss connection. So if you see the policy on the right hand side, so in the policy definition we say SLA class EF, right? So EF stands for expedite forwarding. So any real-time traffic, we use expedite forwarding. So we have defined loss 2 and latency 100. So this is an SLA policy that we have configured. So it will always check if packet loss is more than 2 packets per second, or if the latency is exceeding 100 milliseconds, then it will shift the traffic from this tunnel to another tunnel which meets these SLA numbers. So that's how we define the application aware policy, and we define these SLAs.
Where does this nomenclature come from? You use the word EF. Is that Cisco terminology? Is that Viptela terminology, or is that generic internet technology, IP technology?
It's Cisco quality of service terminology, QoS terminology Cisco use.
Okay. So did Viptela have the same, or did Cisco, once they incorporated Viptela, impose that onto the?
So there are a lot of terminologies that Cisco has bring up in the market, and now they are using as a standard terminology. So now EF is used as a standard terminology, and Viptela is also using EF. Cisco has given a lot of standards in the networking industry, so this is one of them. So the next type of policy is C-float policy. C-float basically monitor traffic flowing through the V-edge routers in the overlay network, and any data traffic. This is it also came out from one of the Cisco terminology, because in Cisco terminology, C-float they call it net flow. So net flow is basically whatever data is flowing in your network, right? And you want to analyze that data for various reasons. You want to see if your application is performance is slow, and you want to analyze the data why application performance is slow, or for any other security reasons you want to see what are the source and destination of your network flows. So you take out that data from the network devices and send it to a collector device. A collector device collects all the data, and this data is completely in raw form. It collects all that data in the raw form, and then it decode that data in user-friendly form, and then you can read that data, and then you can analyze that data for application performance and other issues in your network. So C-float policy is very similar to that. It's basically monitors traffic flowing through V-edge routers in the overlay network and export flows information to a collector where it can be processed by an analyzer. So and then you can generate reports from there. The reports contain information about the flow and data extracted from IP headers of the network. So when you have IP traffic moving between one device to another device, every IP packet has a header, and that header has various kind of information like the source IP address, the destination IP address. Source IP means from where this packet is coming in, and destination where it is going to. Then the port numbers, on what port it is, this information is supposed to go. So those kind of information are there in the IP header. So based on the IP header, it picks up the flows. So and then send this data to a collector, and then collector device basically process the data and generates the reports. So if you see the policy on the right hand side, it's showing you a match condition that says protocol number 17. So every protocol has some numbers assigned to it. So whatever, this is just an example. So whatever protocol that has number 17, it will pick up the flows for that protocol, and it will send those flows into a collector device, and then from the collector device, if you see the bottom part, it's showing you, the last line is showing you collector, which is sitting in VPN 100, and the collector IP address is 11111, and the collector is expecting to listen to this information on port number 4739. So you have to define this information. Where is the collector, and so this policy will generate the flow data, and it will send it to a collector which is sitting on this location on the network. So that's how you define policies for various purposes. And
is this a data plane? Was this data collected for the data plane or the management, the control plane?
No,
and is there a separate policy?
all application data is in data plane. The control plane has only routing information.
No. So is there
So
a
you
similar
apply
template?
these policies like C float policy or application aware policy only on data plane. These
There a
are, you can
similar
say, these are
policy
type
for
of data
control?
plane policies.
Perfect. And I love this because this is how we guys are trained in the radio world. We are trained to start looking for data metrics of success because radio networks are so difficult to make sure they perform. So this is actually where the radio and the network world can meet. But is there a similar policy to capture control plane performance?
You don't want to capture the control plane data because control plane data is only the routing information. The data that you want to analyze is the user data or the application
No,
data.
no, let me challenge you there, my friend. Can I challenge you? Do you allow me to challenge you? So you didn't allow me to challenge you, Faisal. Is that not allowed, or can I ask you a question?
No, sure, go ahead.
So the question is that when Khalid Raza says the network he has built, the data fabric, is the most powerful fabric when it comes to control lane performance. That's its differentiation. The only way you can prove that is through showing control plane performance is better, superior than the competition. So to me, the performance of the control plane is the differentiation point. So how can there be no way to measure the control plane performance based on that logic?
So control plane, you have different control plane policies that you can configure, but I'm talking about the C float policy. In C float policy, you can capture only the data traffic. You don't capture the control traffic.
I agree with you. Thank you. Sorry, and you answered my question. Let's continue. We can come back to this later.
All right. So this is just one slide for cloud access that Viptela overlay extend into public cloud environment and allow enterprises to build IPsec tunnels to the endpoints in the cloud. And this is also from the centralized controller. We can define any policies that can impact the data going between the enterprise network and the cloud.